Matrix multiplication is associative in the following sense. If you have a matrix A that is M by P, a matrix B that is P by Q, and a matrix C that is Q by N, then taking the product BC and then multiplying on the left by A is the same as taking the product AB and then multiplying that to the right by C. This property makes simplification of many matrix computations possible. Now, how would you prove something like this? We won't give all the details here, but one way to approach this is you compare the ij entry on both sides. Say you call this matrix Q and this matrix P, and you want to show that the ij entry of Q is the same as the ij entry of P. And now let me say a few words about the ij entry of a product of matrices. Say I have matrix A that is M by P and a matrix B that is P by N. And now let Q denote the product AB. Well, first of all, if you recall the definition of matrix multiplication, this is given by the matrix with columns AB1 in the first column, AB2 in the second column, and so on, ABN in the nth column. And so the jth column of Q is given by ABJ. So if you look at the ij entry of Q, it will be given by AIBJ, where AI is the ith row of A. It helps to look at a picture. Say this is my matrix A and this is my matrix B. Now I'm looking at row I of A, column J of B. So this is my matrix A and this is my matrix B. Now this entry is AI1 and this one is AI2 and so on up to AIP. And the column J I will have B1J, B2J and so on down to BPJ. This product is given by doing the following. So you pair these up, right? And then you add them up. So this quantity is AI1 times B1J plus AI2 times B2J plus and so on up to AIP times BPJ. So this whole expression gives the ij entry of Q. Now with this, you can try proving this. The proof is not too difficult, but it requires a lot of careful bookkeeping. I hope you'll go through the details and convince yourself of this result. Good luck.